Hello, and welcome to making high-performance web applications with Dominator and Rust. In this video course, you will learn the basics of how to make WebAssembly GUI applications using the Dominator library. You will learn how to do functional reactive programming with the future signals crate, and how to interact with the browser from the WASM runtime. At the end of this course, you will be capable of building high-performance web applications in pure Rust. This course is laid out as one video lesson, teaching a concept or technique, which gives you 1 or 2 homework exercises at the end. You will find the homework in the associated Git repository, link below. The following video will be a longer form video, going through solving the exercises and explaining along the way, before continuing to the next subject. To get the most out of this course, you should be at a decent level with Rust and web technology. If you don't know what the DOM is, or what CSS does, I recommend learning a bit of web basics first, and then come back here. Likewise, if you struggle with basic Rust syntax, this course is not for you. You need at least to be comfortable with lambdas and async programming to keep up. With that out of the way, let's get started! So, what is a Rust plus WebAssembly GUI application? Simply put, it's a Rust application compiled to the WebAssembly bytecode format, executing in a sandbox environment in your browser. The code itself runs at near native speed, vastly outperforming equivalent JavaScript code. From the application, we can interact with the browser's APIs, such as fetch, the DOM, and local storage, via bindings towards the V8 engine runtime. We typically do this using a triplet of crates: WebSys, JSSys, and WASM bindgen. These crates facilitate communicating with the V8 runtime in the browser via automatically generated bindings. WebSys and JSSys use the WebIDL format to generate perfect bindings for all the browser APIs automatically. This means there is nothing you can do in JavaScript that you cannot also do from Rust. Dominator is a library sitting on top of these crates, providing an API to write reactive applications that render into the browser's DOM structure. Let's take a quick look at what a simple Dominator application actually looks like. The WASM main function is the entry point of our application. Be aware that this identifier, WASM main, can be any legal function name. It's not like the main function in bin crate. The important part is the WASM bindgen start annotation. This instructs WASM bindgen to generate JavaScript for us, which will call the method when the WebAssembly module is loaded. We then use the HTML macro to construct the DOM structure. Notice that we provide the tag name we wish to construct. This has to be a valid HTML tag name, otherwise the browser API will fail constructing it. This does not actually create an in-memory Rust representation of the DOM object itself, but instead makes a DOM builder instance where we specify all the properties we wish our DOM node to have. After collecting all the information, the macro creates the DOM node in the browser's DOM directly, giving us what's essentially a handle to the newly created node. The replace DOM method tells the browser to replace the body DOM node with our newly created one. This may sound strange to those of you familiar with the web world, since a lot of frameworks create complex data structures and algorithms to avoid exactly this. The reason this is completely fine, and in fact is what gives Dominator its edge, is that we only update very specific parts of the DOM tree, and only when needed. To run this code, you essentially have two options. You can use Trunk, which is a tool written in Rust to build, bundle, and serve WASM UIs. It facilitates everything you need, including proxying, TLS handling, etc. The other option is use an npm-based workflow using either Rollup or Webpack WASMpack. The Rollup plugin for Rust is written and maintained by the developer of Dominator, so in that sense, it is the most idiomatic. When using Trunk, the index.html file serves as the project definition. It tells Trunk how to build your Rust code and what resources to embed. In this simple example, the only really important bit is the link data trunk rel equals Rust part. This simply tells Trunk that this is a cargo project, and it will build and load it. We can specify many other attributes here, such as relative path of the cargo toml file or custom build flags. When using npm and the Rust rollup plugin, we use the rollup configuration.js file to set up our project. The homework repository has detailed instructions on how to run the exercises and applications. Now, let's have a quick look at making a simple change to the DOM structure. You start out by running npm start or trunk serve at the root of your UI crate. This will start the development server, which will recompile whenever there are changes to your codebase. As we see, we are greeted by our Hello World application. Let's now modify our application to add a subheader saying that we're using Dominator and WASM. We can achieve this by adding a second .child call to our body. This does not replace the previous added child, but instead adds a new child to the node. Alternatively, we can use the .children method, which accepts a list of children, saving us some typing. We now add an h3 node with the text from Dominator and WASM. This should immediately recompile and reload, letting us see the result in the browser. Now that we have a basic web app running, let's look at how to do basic styling. There will be several videos on styling later in the course. This is just to get started. The DOM builder provides us with a .style method. This lets us set the inline style of our element, shown as the element style in the browser's inspect tool. This style has the highest specificity and can only be overridden using the !important in your CSS rule. For the basic use case, we simply call style with the name of the rule we wish to set and the desired value. Here is how to set the font weight of our h1 element to bolder. Just as with HTML tag names, we must provide valid style keys and values. This way of setting style is considered idiomatic Dominator, but you are of course free to use external style sheets and class names as you are used to. To set the class name of an HTML element, simply call the .class method with the desired class name. Since our tooling supports loading SCSS files, it is also very easy to do styling using SCSS. In the exercises to follow, the project is set up to load the example SCSS file under style, so feel free to solve the exercises using SCSS rather than inline styling. We have now reached the end of this lecture, and it is time for some homework. I have put the link in the description to the Git repository you will be working in. The first part of the homework is to install the dev dependencies. I've included instructions on how to do this in the repository, but essentially you will need at least npm and the Rust toolchain working on your system. After your tooling is installed, the second part of the homework is to implement the reference design using Dominator. Here is the penpot design I want you to implement. You'll find this image along with the relevant CSS values to use in the P1's Getting Started application. It is essentially a dialog in the center of the screen, containing a header and 2 columns of text. Don't focus too much on the visuals if you find it difficult to match the design exactly, but play around with the HTML macro and get a feeling for how to compose DOM using Rust code. The design, along with a textual description of the task, is also in the design folder of the homework application. That's it for this video. If you wish to see me solve the homework with commentary, proceed to the next video in the playlist. If you'd rather skip to the next lecture, there's a link in the description. Also, if you have feedback on this course format, don't hesitate to leave a comment in the description. Make sure to like and subscribe, and if you're excited about web development in Rust, share the video with your friends and coworkers. Thanks for watching. Goodbye!